Gosh.
Go commit a crime. Let's go.
I was microwaving a plastic container of refried beans, and when I took it out of the microwave, I dropped it, and they splashed up and landed on my face.
Oh my goodness gracious. No, my God. Okay, so that's
my face.
apparently this is the thing that wakes you up today, is talking about all of our personal traumas. We needed to bring this up in group. My goodness. All right, so we had our stratified cuboidal, which we talked about, also glandular. We're gonna get into our different types of glands today and see how those cuboidal configurations help to have the gland secrete whatever it is that it's created. And then we had our stratified columnar, which we know super rare. We really don't see them. Here we talked about our pseudo-stratified, where it's a false stratification. It all meets the basement membrane, but the nuclei are at different levels, so it does appear to be stratified when it is in fact a faker. He's a wannabe. And usually these cells are going to be ciliated. Show me the interpretive dance for ciliation. We see this anywhere we need to crowd surf stuff like the respiratory tract. The female reproductive tract, it's what crowd surfs the egg gently through the fallopian tubes into the uterus or the uterine horns, depending on what species you are. Here's just our picture. I put a lot of pictures in here. Picture. So now we've got a couple of other categories of epithelium to discuss before we get into our glandular tissue. Transition. Well, what does the word transition mean to you? To move or to change. That's exactly what this cell does. This is the most dramatic shape-changing cell. This is going to be stratified, the transitional is, and where we see this is in areas that need to have a lot of stretch. So we see this in the stomach, the bladder, the uterus, anywhere that needs to be able to stretch without breaking. Specifically the bladder and the stomach, because we get thinner and thinner walls as we get bigger and bigger, and we really don't want stuff like stomach acid and urine leaking out into my abdominal cavity. That's kind of the opposite of what we would want anatomically. And so it forms a leak-proof barrier. Now, one of the issues, just a little tech aside, one of the problems with these transitional epithelial cells, although yes, they are fabulous at changing their shape, they are fabulous at allowing things like the bladder to grow and shrink and grow and shrink. But one of the problems is that they are kind of prone to going rogue and becoming cancer. And so, especially in our
They're the most changing.
What was that?
You said that they are the most changing.
Well, they're very prone to going rogue and forming cancer. And there are certain breeds of dogs, for example, the Shetland sheepdog, miniature schnauzer, are very prone to a bladder cancer called a transitional cell carcinoma. And so transitional cells, although fabulous to allow your bladder to get bigger and smaller, they do sometimes, in some breeds, have this nasty little habit of turning into cancer. So that's our transitional epithelium. It just allows structures to change shape. Oh, I'll give you guys a minute. You're still right.
Ms. Huff, are they prone to cancer because they allowed the cells to keep mutating or to keep dividing?
Not necessarily. It's just, and honestly, I don't have an exact answer to your question. some breeds of dogs are prone to certain types of cancer. And it's just a genetic predisposition. For example, boxers are super prone to having mast cell tumors, which is a cancerous tumor of the skin. Rottweilers are super prone to getting osteosarcomas. You guys tell me what that means. Osteo, sarco, flesh or fleshlight, oma, tumor. So it's a fleshy bone tumor. Rotties are super prone to that. Shelties, bladder cancer. Cavalier King Charles Spaniels, super prone to having heart problems, like something called a DCM, which is dilated cardiomyopathy. So it's just breeds. And learning why we have you spend 8 weeks in your breed identification. I hate that we call it behavior, because it's really not behavior, it's breed identification. But knowing what breeds are prone to what diseases really helps you become a functional member of your medical team and allow your doctor to really bounce ideas. That's kind of the whole point of being an LVT, is that you and your doctor can start discussing and critically thinking cases through. And if you know for a fact that a certain breed is prone to a certain condition, you have to put it on your DDX or your differential diagnosis list. Picture. There's another picture. There's some transitional, and it really does look like a little balloon. When the balloon is deflated, the walls are super thick. When you start inflating the balloon, the walls get thinner and thinner. All right, now we're going to talk about glands. Glands are structures that create things and then put those things either into the blood or somewhere other than the blood. Some of the glands, like we were just talking about eating, you have salivary glands. In fact, as we were talking about guacamole, mine started producing copious amounts of saliva. Yeah, it's that Pavlov effect. So endocrine glands, endo meaning in, these are glands that put stuff directly into the blood. Whenever you put something into the bloodstream, where does it go? It goes everywhere. So endocrine glands have secretions that are going to cause body-wide changes because they go everywhere. Exocrine means anywhere other than the blood. So for example, salivary glands. Now, when you have salivary gland start making saliva, is it causing a body-wide change? No, it's a localized change. Sweat gland, sebaceous gland, anal gland. So the big difference between these two is endocrine into the blood, sweeping body-wide changes. Exocrine outside of the blood, localized changes. We're also going to categorize our glands by how many cells make them up. Are they multicellular? Are they unicellular, meaning they only have a single cell helping to create their secretions? What is their shape? When I test you over this material, again, I am not going to have a picture asking you to identify what kind of gland. I'm just looking for definitions. Do we have a simple shape? Do we have a complex shape? Simple shape is going to be like one single arm, depending on the shape. Complex is going to be where they have multiple arms reaching and creating. What is the structure? Tubular, acinar, tubulo-acinar. These are just the kind of shapes. I've got some pictures coming up to show you the differences. We're going to categorize these glands by what do they make? Mucus or mucoid versus serous. Do you guys know what the term serous means? I can tell you. It means watery. So if you think mucus, Think what Charles is coughing up his lung butter right now. That, that's a great term, right? Lung butter. That is mucus. It's chewy like chewing gum. Saliva, tears, serous, far more watery. And finally, we're going to categorize our glands by how do they release their secretion. We have 3 different types of glands: merocrine, apocrine, and holocrine. Again, you don't have to be furiously writing every word down. I've got slides that are going to go over every single one of these. This is just kind of an introduction slide. Merocrine, apocrine, holocrine just simply refers to if this is my gland and I have now created whatever it is I've created. You know, if it's a salivary gland, it's saliva. If it's an anal gland, it's anal expression. How do we get it out? Merocrine glands just have these little muscular contractions that go and kind of spurt out the secretion. Apocrine glands release the top part of the cell as a transport vehicle. And then holocrine glands release an entire layer of cells as a transport vehicle. I'll tell you some ways that I remember these 3 here in just a minute. So these are all of the categorizations of our glands. Where do they put their stuff? Into the blood, outside of the blood, big sweeping changes, localized changes. How many cells do they have? What kind of shape do they have? What kind of structure? What kind of stuff do they make? And how do they get that stuff out of them? So endocrine glands, as I said, these are going to be depositing their secretions directly into the blood, which means they don't have a duct. When I say the word duct, duct just is something to transport. I think we talked yesterday a little bit about the air conditioner in your house, the air conditioner in this building. It's outside. When the air conditioner turns on, the air filters through a series of ducts, delivering the air throughout the building. The same thing is happening on obviously a much smaller scale. You have a duct, you have a tiny hallway, and that's what's allowing the secretion to exit. Because these glands are depositing their secretions directly into the blood, we don't need that to happen. Basically what happens here is I have my gland, and I have it wrapped in a bed of capillary blood vessels. So whenever it needs to secrete, the capillary blood vessels are able to directly pick up whatever it is, the hormone or the secretion, and then deliver it to the blood. Here I've got, this poor kitty is a little jacked up. Here we've got our pituitary, that's the master gland. It controls every other gland and pretty much everything about your body. Your thyroid and your parathyroid, which controls your metabolism. How easily and quickly are you able to use nutrients? Your adrenal gland produces adrenaline, which is your fight or flight autonomic nervous system. Your kidney, which is an organ, not technically a gland, but it does produce erythropoietin, which produces red blood cells. You don't have to be furiously writing down what all these glands do. It's just so you've heard it before, because I know that in med term and in anatomy, you guys are going to be getting into the endocrine system. So it's just so you've heard these words before. There's Mr. Pancreas. He's probably the most important one because he does both. He has some secretions that go into the blood and some secretions that go outside of the blood. He's the only one that does that. Only one that does both. And then finally, this kitty has both ovaries and testicles. Hermaphroditic, but those are going to provide our reproductive hormones directly into the blood. So yes, and so because these are depositing into the blood, we don't need a duct. We have it wrapped in a bed of capillary blood vessels. So this is a great picture showing, here I have, let me get mine. Here I have an example of an endocrine, and we can see here, there's the glandular tissue. And you see
Ms. Huff?
here, yes?
Charles asked, is the parentheo, I'm sorry, I'm gonna slaughter this. Parenthioid gland on top of the thyroid gland? Perineal gland, sorry.
The what? The parathyroid?
Yeah, my bad.
Okay, yes.
Slaughtered it.
No, that's okay. That's why we learn. The parathyroid, meaning outside or around the thyroid, it's actually like, looks like a tiny pea. Your thyroid actually looks like a butterfly. Kind of looks like this. And it wraps around your trachea. So if my trachea is right here, it wraps around, this is the back of your throat, and it wraps around like this. And then our parathyroids look like tiny little peas that are embedded into the thyroid. And basically why we have a thyroid and parathyroid is because we need to have, if we have an action, what must we also have? A reaction. So the thyroid helps to control and speed up or slow down your metabolism, and the parathyroid helps to react to that.
So you said they're attached to the thyroid?
It's not really attached, they're just, where they're located, they appear to be kind of embedded. So if I have somebody standing in front of me facing you, I'm gonna put my hands into their throat, hook them around their trachea, and fold them like this, so that's how you see it. And then if I put a pea in between my fingers, my fingers don't move like that, but you get the idea.
Yeah, okay.
That's now what we're looking at with the thyroid. Two completely separate structures, but they are in very close proximity to each other.
So the thyroid is faced like this in the back of the neck, or is it this?
Yes.
is the neck?
So I think, well, I do not. So yeah, if, I don't have anything. That's right, that's what I wanted to do. So this bar is now representing, let me not slam myself in the head with this horse leg. This bar is now representing my trachea. Right, imagine this inside my body. And there's the thyroid. It kind of wraps around from the back to the front, but looks similar to a butterfly if you spread it out. It has a very thin band of connective tissue connecting the two sides as it wraps around to the front of the trachea. So that's the thyroid. We'll learn a lot about that in nutrition class because there are some nutrients like iodine that are super important for thyroid function. So this picture really does show, here is our exocrine gland. Exo meaning outside of the blood. And do you see we've got a little hallway exiting the gland? That's the duct I'm talking about. Endocrine gland, here's my glandular tissue. And I have a bed of blood vessels that will enter into the gland, bippity boppity boo, pick up the hormone, and then leave and transport it wherever it needs to go. This gland does not have a hallway. This gland does not have a duct. Endocrine glands do not need ducts. Exocrine glands do. So exocrine, they do have a localized effect. Salivary, we do have exocrine glands in our pancreas. As I said, it's the only structure in your body that does both endo and exocrine. endocrine gland from the pancreas is insulin. Insulin is something that goes into your blood to help regulate your blood glucose. It takes glucose out of the blood and delivers it to the tissue. The exocrine function does have a duct, because exocrine means we need a duct, and it's going to deposit digestive enzymes into the small intestines to help break apart that Chipotle burrito into its most basic structure. Scent glands, obviously we have anal glands, but cats also have glands in their mouths. They're called circummoral glands. And so when the cat is rubbing on you, and you're like, see, I told you he loves me. No. He's marking you. He's saying, this is mine. This is mine. You ever get a thing of donuts and you lick the one that you want? That's what he's doing.
So hungry.
I just love to torture you.
I have a protein bar in my bag.
I've got some downstairs.
Yeah, I'm just gonna torture you because guess what happens when I find a button to push? I'm gonna play with it. Deer also have musk on their antlers or horns. Well, moose antlers, deer horns. And so that's why they rub. Sweat glands. Humans have way more sweat glands. Horses have a large number of sweat glands. They have full body sweat glands. Dogs and cats do not.
I have a question.
Yes,
Okay, so you know, like when I couldn't breathe for a minute.
you're okay.
You know how like when the horse sweats a lot and it creates something that looks like soap?
Yes.
What is it?
So you have oils on the skin as well. And so when the horse is sweating, it will mix with the oils and cause what looks to be, you'll usually see it on horses who have not been recently groomed. Do dogs and cats sweat?
Through their paws, right?
Yeah, input through their paws. If you get a dog or a cat on like the stainless steel exam table, they'll leave little nervous, sweaty paw prints. They can also sweat a little bit in the thin hair of their abdomen, which is why if you have a dog in the summer, you have a tile floor, they come in and do what? Drop right down onto that tile floor because it helps to cool them off by conduction. And then our anal glands. Most animals have anal glands. Canines are the ones that use them primarily for scent. Cats do not.
So there-
Cats do have anal glands, but they don't use them for marking
Is
stuff.
there a reason the goblet cells don't eat ducks?
Because that's how they're made.
That's just what it is.
That's how Groot made us. The goblet cell we all know and love. The goblet cell is a cell unto itself. Wow, that was a lot of cell words. A cell unto itself. He is a unicellular cell. He is an exocrine gland, but he does not have a duct. He deposits his mucus outside of the blood, but he does not need a duct to do it. So that's the one big exception to our rule. Other than this, our exocrine glands have ducts, endocrine glands do not. This is the exception to the rule. Why? Don't know. Because it does.
Wait, can you repeat that? It has no ducts, but it has a what?
So our goblet cell is the one exception to our rule. The rule is if it's an exocrine gland, it has a duct. If it's endocrine gland, it does not. The goblet cell is the one exception. It is an exocrine gland that does not have a duct. And why what?
Why isn't it endocrine? Why isn't it a?
Well, because it's not depositing the mucus into the blood. Endocrine, by definition, it would have to deposit its secretion directly to the bloodstream, and it does not. It deposits its secretion. So generally, the goblet cell, okay, so you have a sweat gland, it produces sweat, it spurts sweat onto your skin, huzzah. The goblet cell is generally associated with another gland and helps to mix its mucus in with another secretion. So for example, your tears. You have a tear duct called a lacrimal duct. The lacrimal duct has a complementing goblet cell. So as your tears are being produced, it's mixing in a small amount of mucus. If you've ever been dehydrated or you've ever had fever, dehydration, you go to wake up and your eyes are glued shut, and you have, some people may not have, but your eyes are glued shut and you have that thick boogers that you're having to peel off. Yeah, that's because when you're dehydrated, I take away the fluid and I'm left with what? The mucus. In my salivary glands, they all have an associating goblet cell that helps to mix in some mucus with the saliva to help to coat. And that's why certain things, like when you're about to vomit, you're gonna have a lot more mucus
Thank you, ma'am.
to coat and protect your structures from any stomach acid. So that is generally the reason why goblet cells don't need a duct, because they're associated with another gland that already has one. Does that make sense? That's about all I know about that. I've just given you everything I got on goblet cells. So here again is just a picture. Here I have my exocrine, and there's the duct, the hallway. Here I have my endocrine. I have my blood coming in and picking up. And then if this were a goblet cell, it would not need a duct because it's helping to mix its secretion with this secretion, and then we use this duct.
So the line in the middle is the duct, or is that like the whole thing?
This whole opening is the duct.
Okay.
The line is just the stuff coming out.
Okay, I see.
Yeah, this whole thing is the duct. So there's our goblet cell. It secretes mucus, mixes with a serous, and does not need a duct. And depending on the structure, that'll determine how much mucus is it mixing. You know, like you have goblet cells in the vaginal cavity. And depending on the stage of estrus that our patient is in, that will determine how much mucus is being emitted in that vaginal canal. There are some stages of estrus where there is more mucus and some where there is less, and that's all governed by the hormones. Again, in our mouths, certain things that you eat will cause our saliva to produce more mucus. Certain things that you drink causes more mucus. If you happen to have a mild intolerance, anybody in here lactose intolerant?
I have the allergy for it.
Yeah, so it's an intolerance. I don't know anyone who's got a true allergy. But usually what happens is you drink the milk, you eat the cheese, and you get either gassy, bloaty, farty, or on the other spectrum, you are now urinating feces out of your butt.
Answer.
Or all of the above, because there's a varying degree. But the funniest thing is, you lactose intolerant people crave dairy more than anyone else on the planet.
Biggest truth.
So the minute that milk or that ice cream, you guys are ice cream fanatics, by the way, it's crazy. The minute that it touches your lips, what immediately happens? you start having massive amounts of mucus forming in your esophagus. Because your body's going, oh, geez, here we go. Oh, gosh. Because now your stomach's going, oh, God. And starts producing crap tons of gastric acid. And so your esophagus already knows that this is going to happen. Your body is, in fact, smarter than you. Your esophagus is like stomach. She's doing it. He's doing it again. He's eating the stupid thing he should not be eating. And stomach's like, oh, God, okay, get ready, because this is happening. And esophagus goes, on it, pal. I got you. I've literally got you covered in mucus. And the goblet cells go, oh, no. And they just start pumping out massive amounts of mucus, because eventually some of that stomach acid might burble up out of the stomach into the esophagus, which is not protected. Meanwhile, your small intestines are also pumping out mucus because they're trying to turn themselves into a slip and slide to get the lactose out as quickly as possible. Does that make a lot of sense for you people that are lactose intolerant? Yes.
Doesn't that make it a great laxative?
I wouldn't recommend it because you're going to be intensely uncomfortable and prone to massive dehydration.
It just constipates me, it doesn't make me go.
Oh my god, so that is the total opposite of what normally happens.
Yep.
Is usually it will cause you to have massive diarrhea.
But I don't have massive constipation.
Good to know.
For 30 days.
So the wonders of the goblet cell, will the wonders of this cell never cease?
We're not even supposed to be treating animals like them, right? Like our
Oh
bodies
god,
really
humans are
work.
disgusting.
Right?
Right?
Yeah.
Humans are gross. We are the only animal on the entire planet that drinks lactate, like nipple juice, far after infancy and from another species.
Other animals can't process it, correct?
No, of course not. In fact, we can't process it.
We just learn to deal with it.
We're not supposed to process it. Yeah, dogs and cats, I know you're like, oh, my cat, I'm going to give him a saucer of milk. Don't. Cats are super lactose intolerant.
That's like the stinkiest litter boxes ever.
Dogs are lactose intolerant. Now, depending on the species, they're slightly more tolerant. Like dogs are slightly more tolerant to goat's milk than they are to bovine milk. Not tolerant totally, though. We're the only animals on the planet that have evolved to drink lactate from another species well past infancy.
Why do we even do it?
I don't know. Who looked at the cow and had white stuff coming out of this little thing and said, let's drink
I have an
that?
answer for this.
That looks amazing.
I genuinely have an answer for this. We started drinking bovine milk because it was so rich in nutrition and we wanted to use every part of an animal that was available to us. And so when mothers couldn't produce milk or when things like that happened in humans, which is super common back thousands of years.
Did you know that actually the only reason we can digest milk kind of is if you're descendants from original herders? So except for like small portions of people from Africa and Europe can only digest milk. That's why a lot of Asian and Saharan Africans can't. Fun fact of the day.
I'm gonna need you to repeat that because we had somebody in the classroom explaining something as well. So you go ahead and tell us one more time.
Oh yeah, so the reason only certain people can digest milk, it was a mutation from herding communities, which is why you only see it in a lot of European and herding African communities and not a whole lot in Asia and non-herding African descendants.
That makes a lot of sense. I'm descended from aliens, so.
Yes, exactly that. And the babies that survive because they drink cow's milk, but could
Evolution.
process it. They passed on their genetics to process milk. And so natural selection.
TIL. TIL.
So probably originally a lot of babies did die because they weren't getting the proper nutrition.
Right.
They couldn't process it. But.
Well, and you gotta also remember, the milk back then would not have been pasteurized, so it was much, 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 much higher in fat content.
Mhm.
TIL.
Drink milk because big milk tells me to build strong bones.
And now we put in our cereal. And eat it.
I
think milk nutrient reality.
No, I don't really care for it.
All right, so we do have some exocrine glands that are multicellular. Obviously, our goblet cell is not one of them. These typical exocrine glands, though, have a secretory unit, which is the thing that makes the stuff, and a duct, which is the thing that gets the stuff out. We just saw like 5 pictures of this configuration. So that's the makeup of our exocrine gland, multicellular secretory unit, which is the thing that makes the stuff, and the duct, which is the thing that moves the stuff. Now I'm just thinking about mucus.
Let's go.
Well, to go with the mucus production from like the dairy, a lot of people don't realize that when we're menstruating, we produce the same amount of mucus. So if you get diarrhea on your period, that's why.
Cause of what now?
Because of the mucus.
So it's like a lot of, like, we don't talk, as women, we don't talk about it that much. It was like, it came about from my conversation with my daughter, who's like 19, and I said something about having period poops, and she's like, that's a thing? And I'm like, yeah, she's like, that makes so much sense now.
Yeah, because your body's just producing it. You have hormones raging, telling your body to do all these things it's not supposed to do. And then your body goes, oh God, okay, we're just gonna do this. All right, let's just get this over with. Bam.
Where's the duct moving the secretion to?
To wherever it needs to. So if you think about, here, I'm gonna draw you a little gross picture because we're in that place right now. I have now drawn a duct. This and exocrine gland happens to be a sebaceous gland, meaning that it produces oil. So it's producing oil, producing oil, producing oil in the secretory unit. And then it's depositing its oil out onto the skin. However, what do you think happens if I develop a little plug right here? I'm still creating the oil, the oil, the oil, the oil. Can't get it out. And this starts to swell. And now your immune system gets involved and goes, oh Lord, okay, hey, go take some of the military guys, go figure out what's happening over there. And they go and they find out what's happening, and then some of them die. And it gets bigger, and more of them die, and it gets bigger. And now you've got this ginormous whitehead. And when you do the most satisfying thing that we all do, don't tell me you don't, because I call you a liar to your face, and you do it, what you're doing is you're squeezing the secretory unit, putting putting pressure. Stop. Get my pen back. Putting pressure, causing the plug to pop out, usually onto the mirror. And you've now squeezed and you've emptied it through the duct. So that gives you a nice visual of what I'm talking about as far as the secretory unit, the duct, and where is it secreting its stuff to.
Like that old movie, The Blob.
Yeah. we've got some shapes. Remember, we've got simple and compound. Simple are just that, simple shapes. Compound are gonna have multiple branches, multiple branches, very complex. I am not going to test you on the individual shapes. So I'm not gonna put like this picture and say what shape of gland is this. Not gonna happen. This is mainly for your own information. We just mainly need to know that we do have simple and compound or complex. All right, so now we're going to move on to, we made the stuff, we're still talking about exocrine glands. We made the stuff, how do we get the stuff out? We have 3 different types of glands: merocrine, apocrine, holocrine. Merocrine glands have a little muscle contraction and they just spurt the stuff out. There's no damage to any cell component of the gland. Apocrine, the top part of the cell is released and it transports its secretion where it needs to go. Holocrine, an entire top layer of cell, the entire cell is released and transports. How do I remember these 3? Merocrine. Okay, I don't have regular TV anymore, but some of you might. A while back, there was the most adorable show ever. It was called Meerkat Mansion. So, does anyone know what I mean by meerkat? Go to the zoo if you don't. Meerkats are adorable. They burrow these very complex burrows under the ground. And the meerkat will pop up adorably out of the hole and just stand there looking for danger.
Is this both for this classification of exocrine glands? Is this multicellular and unicellular?
Yes.
Thank you.
So these merocrine, I think of the word meerkat. When the meerkat, pretend the meerkat is the secretion. When the meerkat comes up out of the hole, did the whole burrow collapse behind him? Hopefully not. For our story, it did not. It remains completely intact. If you think of the meerkat as the secretion, the meerkat can come out and the entire tubular structure remains intact.
You could say it's a miracle.
It is a miracle. The meerkat, merocrine, no cellular sacrifice. Holocrine, yes, I skipped one. Holocrine, I pronounce it as holocrine. The whole cell is released. This is why we need some of our multicellular, some of our stratified glandular tissue, because when the whole top layer of cell, we've got another cell behind it to replace. So meerkat, merocrine, no cellular sacrifice. Holocrine, the whole cell. Apo, tell me the medical term. Apo means what? Derived from. Apocrine, the top part of the cell, is derived. The cell is not fully sacrificed, just the top part of the cell is released. That's how I remember these 3. And honestly, if you can remember the meerkat, merocrine, and the holocrine, then by reason of elimination, you know what the apocrine is.
Can I share a fun Disney meerkat fact?
I would love it.
All right, so there are researchers that collect owl pellets in and around the Houston area to research owls, and they kept finding meerkats in the owl pellets because the Houston Zoo meerkat enclosure has an open top. The meerkats can't get out, so now they have to bring the meerkats in at night.
Oh dear.
Because the owls were snatching meerkats.
Oh, that's a terrible, terrible meerkat. Why would you do that?
I mean, it's interesting thing, like they would notice, they'd be like, wait, shouldn't we have like 25? I only counted 23,
I only
but
have
there are
4
meerkats in there
left.
everywhere. You know, I guess they just weren't keeping count of the meerkats, and like the owl researchers had to go to the zoo and be like, we think the owls are eating your meerkats.
Wow, I have so many owls around my house. I do. I have like 3 of them and they're humongous. These things, I assume by looking at them from a distance, that if they were standing next to me, they'd be about 2.5 feet tall. These things are massive.
My favorite thing that happened after I moved to Texas was I went outside to take my daughter to preschool. But I went outside and it had rained the day before, so there was puddles in the gutters, and there was an owl bathing in the gutter in front of our house.
Wow.
And just left. He was like, no, thank you. Right? They're massive and they're incredible. I love birds.
They're amazing. They're so huge. I talk to them and they sing back to me. I'll be in my backyard and I'll see one and I'll just be like, hoo, hoo, and they'll go talk back to me. And then I get both of my girls inside hastily because they'll snatch them up and eat them. Here I have one of a series of pictures. Here I have, get my laser pointer going here. Miracrine. No, so there's the gland. No cellular sacrifice. Apocrine. Here's the gland. It releases its secretions to the top portion of the cell. The top portion of the cell is released. The cell will then create a new top portion and re-release the secretion. Holocrine, we have the entire cell releasing the secretion. And you can see here, we've got several stages of mitosis to replace the cells that are being sacrificed. Miracrine, here we have the gland. The cells are producing. We have a little muscle that just kind of spurts it out of the duct. No sacrifice. The tunnel is saved. Apocrine, again, we have our secretory unit that secretes into the top part of the cell, and that top part of the cell is released, and that's what transports our secretion. And then finally, our holocrine, the whole cell is released, and that's what transports our secretion. Is everybody okay with the 3 different types of secretion? Finally, we classify. Do you see how all of these slides were just elaboration on that very first slide of classifications? Finally, our classification, what does it produce? Is it watery? Is it mucus? So we've got serous, which is watery, and some are both. Some are mucoid or serous mucus. But we have the very watery and the very mucus, the very thick, and then some have a combination of both. Like I said, your tears. Your tears are made of protein, water, and mucus. Your saliva, water and mucus, both. And so that's what our final classification of the glands. What do they make? There are certain breeds of dogs, just while you're writing, that are very prone to lacrimal or lacrimal duct irregularities. For example, Cocker Spaniels. Cocker Spaniels develop, did you guys learn about KCS? Keratoconjunctivitis sicca. You will. But basically, have you ever seen a Cocker Spaniel with super gummy mucus eyes? They almost get a green film on the eyes. That's because they're underproducing the serous portion and they're left with the mucoid portion, and they have a diminished tear production. And so they'll develop this really thick, dry mucus on the eyeball and around the eye. And we need to treat them with eye drops to help keep the eye moisturized. It's called keratoconjunctivitis sicca. Calves, any of your bug-eyed dogs. You know, the bug-eyed dogs are prone to it. Comments, questions, concerns so far? We've covered a lot of material. I want to make sure. Have I gone too fast, too slow? Everybody on the bus?
Yeah, the picture stuff can help.
Yeah, I love the pictures. And that's why, again, this is a 110 slide PowerPoint, because I have half of it is pictures to show you.
Does urine have both?
I'm sorry, what was that?
Charles probably got to type it in so someone can ask.
He
Is
answered about
urine
your,
in the
I'm getting two people talking. What?
sorry, he's asking about urine. Does urine have both?
No, so urine is actually not a glandular secretion. Urine is an entity unto itself. So it is not a glandular secretion. It is the remnants of what's left over after your kidneys get done with your blood. Your kidney's job, we think that our kidney's job to produce urine would be to get rid of stuff. Your kidney's job is actually the opposite. Your kidney's job is to hang on to stuff. And so it hangs on to things like electrolytes, like sodium, potassium, chloride, calcium, phosphorus, all this really groovy stuff that you need. The kidney's job is also to hang on to as much water as it possibly can. In fact, only about 1% of the stuff that gets filtered from the kidneys is evacuated by your body. And so when we have water and proteins and excess minerals and electrolytes, and of course toxins, that's when we develop urine, and then you evacuate it out of the body. So the urinary system, although yes, is water, urine is water, it is not a gland. Gland is an entity unto itself. All right, so now we're going to move into the next second type of tissue. That's it for our epithelial tissue. Now we moved into tissue number 2, the connective tissue. Guess what connective tissue does? It connects stuff. We're going to see it in the skeletal system. Tell me the type of tissue that connects bones to bones. Ligaments. And muscles to bones. Tendons. We have connective tissue. What does the word integumentary mean? Skin. Tell me another medical term for skin. Dermo, dermato. Like collagen, elasticity of also fascia. And depending on where this connective tissue is, the appearance will vary. The collagen in your face looks very different than the ligament holding your scapula and your humerus together. We have this connective tissue having different forms and functions, different types of fibers. It acts as a reserve for energy. Fat is also considered a connective tissue, which is your primary energy reserve. Protection, again, fat is a protection. And it provides the framework. It also provides the attachment points so that we can use our skeletal system as a series of levers that allow our muscles and skeletal system to provide movement. Very similar to a puppet on the strings. And then our connective tissue is very highly vascularized. In comparison, remember our epithelial tissue not vascularized but innervated. Connective tissue highly vascularized. A lot of blood supply. And so this is just the intro. I do this PowerPoint the exact same way. I know it's a lot of words, But this one slide contains the majority of the information that we need to cover over this particular part, this particular tissue. So that's going to be our handshake, how do you do, because time flies when we're having fun. We've covered a tremendous amount of material today. So number one, excellent job, everyone. You guys are amazing. Number two, I want to just make sure and double check, is everybody on the bus with your epithelial glandular tissue?
I think so.
Fabulous. Okay, so if you will read ahead and just look over our connective tissue, we're going to pick it up here on tomorrow and cover it. And then we'll do the final two types, the nervous and the muscular. And then our tissue chapter is complete. And then we move on to the skeletal system.
Will the test probably be on Monday?
I would anticipate, but we'll see how far we get.
Okay.